All right, good evening, everybody. Um, it's it's been a while. Um, I actually gave some time for people to play around with tax tree, which was just Ross Passy. Do you still remember the essentials we covered in the last class where we talked about nodes, topics, and things like that? Okay, a few people do. All right, so um, today's approach is going to be a bit different. The idea is I want to I want to give you 5, 8, 7, 10, 8, 3, 8. Um, okay. It's so burnt out. Okay, can you guys see my screen? Okay, so today I want to use a different approach, right? Up until now we've been looking at from the concept to the maths and then application, and like we all know the flow so far. And so far it has been okay, it has been good. At least you can properly layer the knowledge so you can see where we start from, where we are going to, and like everything on the grand scheme of things. This time around, uh please, is it just me that hasn't seen the Rust 2 class slide? Yeah, I believe it's just you. I believe it's just you. And I should probably resend it. So what did you do? Latifa, what did you use to do your tax tree if you've not seen the slide? Did you even do tax tree? I mean, there was no submission for tax tree, so I can't really check who did or who didn't.
Um, I have not done task 3. I've not done task 3
Okay. And have
because
you?
I can't copy from the slide.
You
I've
can't
not
copy
seen.
from the slide.
Yes, I can't. I've not seen the slide.
Wait, is
I've
the
checked
problem you can't
slides
copy from
and
the slide, or you've not seen the slide?
I've not seen the slide, so I can't copy.
I mean, you don't necessarily have to copy from the slide per se, but let me let me show you something. Have you seen have you like gone through the recording? Were you in the class?
I was not in the class, but I've gone to the recording.
Okay. Okay. Let me send you the slide in that case. I'll drop it on the group again. because that sort of affects what we are going to do today, actually. Okay, so we have that now. Oh, all right. So let's start with probably don't have much time. So for people that did tax 3, we would find out that it was just that stick, like the two link mechanism, the two link robot arm. It was like the simplified version. There was no extra thing to it, and just to control it like that. But if you run other examples, because that source folder that you guys cloned, it had other examples. That 2D link example was example 1. There are about 11, 12 examples there. So you can actually run it, the same command for running example 1, you can replace it with 2, and it's going to run example 2, and like that, and then you get different examples. Right, good. So this time around, we want to say, okay, why are we using stick? Let's use the actual robots. What does it take to use the actual robots? If you notice, the actual robots are not sticks. Then maybe for someone that has not seen a robotic arm in real life, let's go with IWA 14. Let me show you. So this is a very popular robotic arm. Very popular arm. This is basically what it looks like in real life. So as you can see, it is not all sticks. As a matter of fact, if it were to be all sticks, it won't be able to function the way the way we would want it to function and things like that. So how do we now apply all what we've been learning to the actual robotic arm? And that's the question that I have decided to, like, we're going to tackle today. I know how to do that. In order to do that, I want to paint a scenario. I want to paint a picture as though you all got this particular job in the real life, or you guys got, I mean, for whatsoever reason. I'm just giving you the experience, how it is done, at least to the best of my experience. All right. Share this style instead. Okay. Got it. And then comes on here. Okay. Again, today's class, right? Any, like, you might raise up your hand, you might raise your hand, I might not see it. We are going to be doing some form of live coding, right? So I'm going to be coding live, so that I'll show you, because this particular task that you will do, I can't just leave it. I mean, some of you would figure out how to do it, but I mean, I'm going to show you how to do it on the spot, right? You can easily reproduce it, but it is such that reproducing it still needs some form of critical thinking. So it's not copy and paste per se. So we're going to be coding live, and there are times that you would, before you raise hand, before I'll see it, I've probably passed what your question is about or something. Yeah, so things tend to move very fast when we're coding live. So just feel free to unmute your mic at any point in time and just interrupt. I'll definitely go back. Every other thing remains the same. All right, so for this, I'm trying to paint a scenario. I'm trying to paint a picture. This is usually how it happens, or at least some part of it. This is how it happens. A company has an idea in mind. They want to design a robot, right? For those of us that did engineering or mechanical engineering, before we design, we do this thing called, like, we make sketches, right? We have the idea, we know how these things should move. We don't know how they are going to move yet, but you know that you can actually do some CAD and say, okay, these are the parts, right? The act of knowing how they move would now be done by someone who is like specialized in that field. Same thing applies for the robotic arm. Somebody can design the parts elsewhere, and then you have the parts now, but you need to know how they all come together, or how the simulation works. You need to see the parts move, right? I already explained this whole simulation thing in like the second, third class, where you can probably go back to that recording and get a full understanding of it. But basically, we are provided with some form of card already. We would go into detail what card is that, because it's not like the regular SolidWorks files or whatever. Okay, so basically, I just decided to make it a bit dramatic. You can read all of this, but it's just to set the theme. Basically, we are going to be working with free versions of popular company parts. So what I did was, there are repositories online scattered all over GitHub that hosts the card of popular robotic companies. Some of them are maintained by the company themselves. Some of them are maintained by third party. Some of them I just stumbled upon them and I was surprised that they are there. Or either ways. So I decided to like take all of them, put them all together. The idea now is, look at it this way. These companies are reaching out to you to work for them. The specification and everything would be given to you, but it's so that you would understand how you would actually apply all that you've been learning to what we're about to do. Okay, basically, we're looking at some companies here: Fanuc, Franca, Kinova, Kuka, U Factory, Unit 3, Universal Robots. What I would appreciate if you guys do is, for all these companies, you might probably want to read about them. Why? Understanding some of all these companies in real life makes you understand a bit more about robotics, makes you actually see from a company's perspective what they are actually doing. So what they want now is, as I've said, if you are manufacturing something, you would get your mechanical design, but that's just the solid part of it, like the actual part of it, the part that is going to control the joints, that's going to control the gripper. Let's assume it's an assembly car, or a robot hand for welding. The part that actually makes those motions and carry out the welding is done by software. The mechanical parts is the physical part, you see the motors and everything. But what drives them per se is software. And there are, although not it's not compulsory that you use ROS, because I think Kuka uses their own programming language that they invented. But since we are learning ROS, we would find out how we can actually integrate ROS to pure mechanical design, such that we can actually control it as though we are doing it in real life. So I don't know if you get the idea of what I'm trying to pass across. Okay, so this is how we're going to do it. There are a lot of write-up before now. The write-up is for your tax, when you read the tax, so you properly understand it. The write-up is just a summary of all what I've said. Right. Now, first of all, there are some keywords we need to understand. They said they've built the mechanical design, and what they want is ROS2 integration. At least everybody here knows what mechanical design is, and if you don't know, it's just designing the mechanical part. I mean, that's a very bad definition. But mechanical design is the whole thought process behind creating something. So you want to create a car, for example. You think, what should a car have? Wheels, engines. Though that whole cycle is mechanical design. And then you somehow say, okay, all this, the wheel, the engine, the chassis, it's in my head. It's something I'm thinking. Let me be able to put it in a way that someone else can see it and say, oh, this is what you're working on. And then you come up with a car design, computer aided design, and then you design the car, right? The car doesn't move. Even in the laptop, the car doesn't move. You probably have to do some extra simulation to make it move, right? But at least you have a design that you can show someone. Anybody can know that, okay, yeah, that's a car, but they don't know how the car moves. The same way you can see a robot arm, can say, oh, that's a robot arm from the mechanical design, but you don't know how the robot arm moves. Now, we are the ones moving it, simply put. So, what exactly is integration? When they say, oh, ROS integration, because there are like so many jobs that they just tell you the description is you're going to integrate ROS. ROS integration depends on the robotic system you want to integrate it with. At least we're talking about robotic arms now, so let's focus on that. What it basically means is you take the robot's mechanical design and then you make it usable. The idea is to be able to control it. You make it usable, you make it controllable, and then you test it. So we'll come into more details. But for now, you can see some few visuals on the screen. ROS 2, which obviously is what we are focusing on for this week. We have Gazebo. We installed Gazebo previously. We have RVs. The last class we looked at RVs, but we are going to use it more today. Now, robot control is another thing. For some of us that know what control systems are, this is the part that actually, like, the maths that govern how the robot actually moves. And then we have Move It for implementation. This is a package for us too, and we'll still come to it soon. All right, so basically, if you remember the first class we had, I talked about if you have the robot in the physical space, like you can touch the robot. In order to control it, in order to do anything at all, you need to find a way to describe that robot in the computer. And it's something I've gone over. It's something I've gone over severally. The first class we had where we had to describe a robot, we used 4 parameters: L1, L2, theta 1, theta 2. That was the very first class that we had. But now this will not be enough, because if you notice now we're in 3 dimensions. In 3 dimensions, we have 3 more angles. We have a lot of things I explained in the class on homogeneous transforms. So we can't use L1, L2 and all of that. Now, something else that we use is called URDF, which is Unified Robot Description Format. So URDF is basically we'll come to what a URDF actually looks like, but think of it as the file that combines every single thing about a robot that the laptop or the computer or your PC needs to know about that robot. Now, this robot description layer, as you can see, there is URDF, there is Zacro. We're not going into Zacro now, but eventually we'll have to come into Zacro. But in order to understand Zacro, you need to understand URDF first, because Zacro is just URDF on steroids. All right, so simply put, robot description layer is always the first step of ROS2 integration. Is the foundation of everything. Now, basically, we convert CAD into meshes. Now, if you do CAD, whether it's an OBJ, whether it's step, any form of CAD, if it's SolidWorks format or it's whatever CAD you do, you must always convert into mesh first, which is STL or DAE. And basically, meshes are simpler formats. They really don't carry so much details. It just represents your CAD in series of connected triangles. If you want a finer mesh, the triangles are like far smaller, more detailed, but that's besides the point. That's a problem of geometry. But at least now we know that the CAD will be given, and the idea is to convert that CAD into mesh. Now, from that mesh, we can now use our URDF. We can now define links. Remember, the first time we had to define a robot, we had to define links L1, L2, theta 1, theta 2. But this time around, we are defining links in a different way, which we would see. So we still have to define links, the joints, which is the connection of the links. Now we have two things we've introduced, origins and limits. We'll come to that when we'll actually see what a URDF file looks like. Now we have inertia, collision, and visual elements. Visual elements is what the robot looks like. Collision is how the robot interacts with itself and with other things. If you have ever used any 3D animating or animation software, you will understand, okay, you know what collision is. Without collision, a ball will pass through the wall. It's when you have collision on the ball or you have collision on the wall that there's some form of, like, it tells, okay, that's a hard surface. That's how the interaction is defined. Now there's inertia. Inertia basically explains how much it weighs, how much that robot part weighs, and how it reacts to forces. So again, at this point in time, we are not so bothered about this. We just want the visual first. We just want to be able to see the robots, to visualize the robots. So we're going to visualize the robot in RVs, and then once we have the robot in RVs, that's when we can do anything that we want to do, because all of the ROS ecosystem understands URDF, either URDF or Zacro. So other things that you can also do is motion planning, but motion planning is a bit, it's out of our reach right now. But one of the things that you can relate to in motion planning is kinematics, because we talked about kinematics. And in this case, we're not going to do any manual computation. We're not going to, everything is basically, as I showed you in the previous class, everything is already solved. The reason why we went through that phase, also you actually understand that on a lower level, this is what's going on. You know the whole idea and the maths, the concept behind everything. So you're not just using the software just like that. Another thing that is obtainable too in integration is path planning, motion execution, collision checking. Again, these are slightly advanced topics that we're not looking at. Out of all these four things, the only thing we looked at is kinematics. Along the way, we might do trajectory, but let's see how far we go. Now this is control. Control is beautiful. Basically, you derive the governing equations for the system, and then you code it, and then you tune it. It's a process. We're going to have like a week on control. How many weeks do we have left? We have like 3 weeks left. But we're going to have a class on control where we would actually see, okay, yeah, because you can't talk about robotics without control. It just doesn't really make sense actually. Control it's a completely different domain actually, because it's not only in robotics that you use control. You use control in mechanical, you use control in even in civil engineering. There's control and all of that. So it'd be nice to still talk about it. Then hardware integration. Although this is in the case where we have the hardware. If you don't have the hardware, you basically just need to do simulation to real, sim to real. Sim to real is where you have your software solutions, your simulation solutions, and then you test it on the actual hardware. And all you need to do is just to adjust the discrepancies. What's that? Don't send a message on the group. Okay. Okay, so that's basically what. Oh yeah, I was talking about hardware, sim to real. Okay, so you have your software simulation, the results and everything, and the code that you're going to actually try out, and then it works in simulation. So you now have to try it on the real hardware. If there is any difference, if there's any adjustment, you just basically fine tune it and things like that. Now let's go to URDF, and this is where things get a little bit confusing. URDF is basically an XML. For those of us that know XML, XML is something everybody must have used. It's just this file format where you use angle brackets to group values to their variables and things like that. You just organize it, and then the computer knows how to read it, right? We'll look at that practically. So basically, we define links, we define joints, we define material, geometry, inertia. We'll look at it and look at the consequences, like how it affects the things we are doing. Yeah, I think that way is that way the slide ends. Okay, so at this point in time, let's just go straight to, because today is more of like me doing stuff and you seeing how stuff gets done. Yeah, I'm going to stop sharing this, and then I will have share my entire window. Okay, so we have the entire window. We have the entire window shared. All right. Let's assume you create a new folder and you call it tax4. We're in that new folder now. Let me make things a bit bigger here. Let me open terminal and let me see. Let me make this bigger terminal. Bigger terminal. Okay, so everybody can probably see what I'm doing. So let me create a file called tax4 guide. I actually haven't written a guide. I've been so busy. MD format, tax4 MD. Okay, so we have tax4 MD there. Well, I would say tax4 guide. All right.
Bakio, I think someone is trying to call your attention to something.
What was it saying? On the
Silent
group, raise this hand in the chat.
in the chat.
Can you please give a very quick recap? Don't worry, I'll give a recap. My assumption is I just come back for prayer. I'll give a recap, don't worry. Right now, I am, what am I doing now? I am showing you guys through tax4, because tax4 is both the class, the lecture, and the assignments. I mean, it's not supposed to be so, but I've been so busy doing whatever it is I've been doing. Okay, so no, not split editor. Readme, right? Tax guide. Okay, so the first thing you're going to do is open the repo, and let me show you what repo that we are going to clone. Okay, so what are we trying to do exactly? Sahid, we are saying that, wait, did you miss out from the beginning of the class? Where am I recapping from? Okay, we're on GitHub. I should go to my repositories, and then we have a tax4 repo. I literally just did this 4 hours ago. I mean, it's been a crazy crazy week for me. Clone the repository. We'll have that down. I'll put it in a bash and then git clone. No, you're not going to clone the repository. You're going to fork the repository. Fork the repository. This is the repository you're going to fork. Head over to the repository, fork it. I think this is going to be a better option than this. Okay, then close it now. Okay, great. We fork the repository. Now, the repository has a README. Like, you have to develop the habit of reading, right? But the reason why I'm giving this guide is because the README is very long and it has a lot of robotic arms and also some robotic dogs. And it might be pretty confusing what exactly you want to do and in order to save time, whatever. So you come to the repository. After you fork the repository, you're going to have a copy of the repository. I'm going to send I told you guys to pick random numbers. Those random numbers correlate to some of the robots that is like here, right? So I am going to send you a picture that shows your name against which robot you are going to use, all of that. But let's assume now I'm going to solve for a robot that nobody has. So 0.2. Osanyadi, are you lost? So we fork the repository, and then after I fork the repository, clone it. 3, head over to your robots folder because you have one from the lots. But I will share it on the group. Okay, and then 4, after I head over to the folder, there's a common structure in the folder. Let me clone the repository so you see. So let's assume you fork the repository and now you want to clone it. So git clone it's going to take a while because it contains a lot of robots, right? So let's assume your folder is unitary go. Nobody actually has that folder because that's a bit complex robot. Nobody has that folder. So what you're going to do is you would go to the folder. All folders look alike. They have a final result and they have files like this. This one, it has a final result and it has files like this. They are all the same thing. A final result and they have files. That's how everybody's folder would look like. But if you notice, some files are DAE, some files are STL, right? So head over to your folder, open your folder. That for example, let's assume this is your folder. For example, this is your folder. All right. Now, the first thing you do, all folders have the same structure. Some with STL, others with DAE. Now, if you ask what's STL and what's DAE, if we go back to the slide, I talked about something here where I said they give you the card in form of meshes, STL or DAE. Why? Because CAD files are, I mean, some of you use SolidWorks and you see how long SolidWorks might lag on a bad laptop, let alone on when we're trying to run a couple of codes with it. So we want like the lightest thing possible, right? So STL or DAE, and I'll show you how those things actually look like. So they all have the same structure, some with STL, others with DAE. Now the overall goal is to build the robots, build brackets, assemble the robots such that it resembles the pictures in the final results folder. So now if you open this, there's a final results folder. If I open this for you, this just looks like this. I don't know if you can see it. It's basically just components. Now you can't really tell what part this is from just looking at it. That's why it is named base link. Link 1. Look at this. It looks very odd, but link 2, this is another link. Basically, this is how the components come. Even like if you're working on it industrially, they just like export it like this for you. And then they give you, in the final results, we have two things to guide us. We have this picture where we have what it looks like. Then we also have this particular picture. With this, you can have a rough idea of where what goes, right? Yeah, what's up, Samuel?
I want to ask, are those links usually named link 1, or they could be named something else?
Okay, so let's look at the conventions. This one was named finger hand link 0, link 1, link 2, link 3, link 4, link 5, link 6, link 7. This was named arm link, base link, forearm link, lower wrist, shoulder, upper wrist link. This is exactly how they named it. This was link 0, link 1, link 2. But in either ways, provided it's a robotic arm, it's easy for you to use your intuition to know where what goes. In the event that you do not know where what goes, that's when you now have, there's always the final result. We know what it's supposed to look like at the end of the day. I mean, they designed it, they know what it's supposed to look like. So you would look at the final results, you would look at what link you are working with, what link are you working with, and then you can like tell where what goes. It's basically, at this point now, it's more like putting the puzzles together. But again, that's what makes it fun. So you see this link here, you see this link here, and then you probably see this one. And then, okay, and then you now have this guy. So it's left for you to now try and figure out how they actually come together. And the funny thing is, it's that figuring out that is usually part of the problem. Already you can see that, if I should zoom this part, you can see that this point up here is this one. You can see this arm here. Now, just on a bit. Yeah. Blah. Now, why am I not using the proper CAD software? Again, I only use CAD on gunpoint. So there's somebody on this group that is like, that likes the CAD part of robotics. No, that's not what we do. We either do software or hardware. We don't do CAD. So yeah. Do I have CAD softwares? Yes. At times you might have to go, you might have to do some CAD. But in a proper setting, the CAD has already been done for you. All you just need to do is tell them, oh, I need it in STL. I can't use it in step. I can't use it in which other file formats are there, SolidWorks or SolidWorks parts or whatever. So I'm just trying to give the rough overview. Now, in cases where, in cases like this, like no matter how complex the robot is, I'm sure maybe some of you must have seen something like this, the robot dog. It's pretty popular and it's pretty nice to work with. So even this, regardless of how complex it might be, can still be defined in URDF, and it still follows the same procedure. Although for this particular, okay, so let me tell you what happened. All these files were in Zacro. They were not really in URDF. URDF is like the easy way. All of them were in Zacro. So I had to, that's what I was saying on the group at one time. I had to like write them from Zacro to URDF to see that it works with URDF. And then, because like we're starting from URDF, so it's going to work with URDF, but there's advantage for using Zacro and all of that. So yeah, and some of all these robots were on ROS 1, so still had to port it to ROS 2. But again, we have successfully reverse engineered it, and all we have is we strip it down to the minimum. That's what they give to us, and now we are going to build everything up from scratch. So if you're on a Windows machine and you have SolidWorks, you are at a good advantage because you can easily view all of this, right? If you're also on Linux, you can view it. As a matter of fact, Linux is pretty good. You can get FreeCAD, or you can use MeshLab, let's say hip.dae, and I probably want the full scene, and then I get this. It's not like I need this for anything, but as we go on, you would find out that at times you might want to make measurements. At times you might want to measure to know where what is. But this is like a very something would settle into like as time goes on. You would want to measure from maybe this point to this point, and like you would want to know what the measurement is reading. You know, there are different reasons you might want to measure, but I would show you why you would need to measure at some point. Yeah, the measurement even shows here. That's why I like the terminal open, because like almost everything you do in GUI shows on terminal. There's some Chinese in it. Okay, that's extra stuff. Now let me put this in the part of here. Okay, so what tools should you have beforehand? If you have SolidWorks, perfect. Like perfect. You don't want to get SolidWorks. I don't have SolidWorks on this PC, so I use MeshLab. Right? And how do you get MeshLab? Sudo apt install MeshLab. I mean, you can choose to put -y, well, optional. Sudo apt install MeshLab should do the trick for you. And I would probably want to bash this. What tool should I use? Number 1, MeshLab. Number 2, yeah. So just bash this. Just standard movements. Okay. I would want to do 1, 2, 3. I would want to make this hash. No, just formatting. And my overall goals, I would also love to make it hash. Okay, that's our overall goal. That's good. Okay. So good. Basically, you are getting the overall idea of what we are going to do, and we are going to also We're going to see how it works. Now, you've opened the folder, you've seen everything. This is where you actually start working. First of all, remember the idea is ROS. We are to integrate it with ROS. Whatever we are doing, we're integrating it with ROS. So the first thing we're going to do is to create a ROS to package. Now, we'll do that practically. Let's assume you cloned the website, right? You cloned the repo. This is everything. Let us assume that the dog, because nobody has the dogs actually. The dogs are pretty complicated to assemble. So we take the dog, that's yours. It's going to be easier for you if you just go outside that Git, because this is a Git, this is a repository. This particular one, it's a repository, and if you try and initialize another repository inside here, you're going to have an error, except you delete this Git. And I mean, I don't recommend you starting that habit, but simply just go outside and go to another one. Say, okay, tax, you call it tax 4 submission, tax 4 submission, and we're going to tax 4 submission, and then you paste your folder. That's what you're working with. Okay, so I can say 1.1. 1.1. No, okay, it doesn't work that way. Okay, so create a new folder outside the cloned folder. 3, copy your assigned robots folder into the new folder. Now, we have this inside the new folder. Next thing you are going to do, in this new folder, you can choose to create a workspace, assignment, or tax 4 workspace. Tax 4 workspace. Now we have a workspace. Again, I've told you, workspace is that place where you want to have all your ROS things inside. So, okay, everything you're doing is inside there. Anything ROS, because ROS gets very scattered the moment you go outside the workspace and want to just do everything. So open the terminal. The first thing I said was create your ROS2 package, right? Now, how do you create a package in ROS2? First of all, if you want to do anything in ROS2, most of the things in ROS, most of the commands, it's not mandatory, but let me see. Are there any questions for me? How did you open anything? How about Fusion 360? Yeah, you can use Fusion 360. I've never used Fusion 360 before, but you can use Fusion 360. It works. It works actually. I'm coming. Okay, see that. See, even the tabs get tabs. This is just tabs, but then there are windows, like more windows, and or just now unlimited RAM because I'm okay. So ROS2, the command to create a package is ROS2 package create, and then the name of the package. What's the name of the package you want? I want to call it. Almost everything is tax 4. So maybe dog. Okay. Dog. Now, good. You need to learn conventions. If you are creating a package with URDF, you call it the robots underscore description. Is it compulsory? No. But let me show you something. This is These are the raw, the raw repositories that contains the descriptions. So what I did was I came here. There are a lot of folders, right? But then I see description. I instantly know that this is where the cards would be, because description. I open description, I play around a bit. I see gazebo. I know it's not going to be in gazebo. What hold gazebo is SRDS most likely. So I know meshes. It's going to be in meshes. Okay, I can see different types of robots. I open here. I can see collision. I know it's not collision. I know it's visual. So I open visual and look at it. So there are a lot of why? Simply because I know the convention, right? If I was to look for control and I come here, oh yeah, this is the control, and I have the things that I'm looking for. The controls will be in the source because C++, obviously, these are the controllers that I'm looking for. And there's admittance control and there are a lot of other things. Oh, top control. Sorry, I digressed. So there are a lot of things. You should just know the conventions so that you would know that, okay, yeah, whatever package you are using can be used by another person. Okay, that's the idea of the whole ROS in the first place, open source. So we're creating dog description. And then the next thing you want to do is, remember we said ROS can be written with Python, C++, Rust, and then of recent JavaScript. Again, I'm not a fan of that, but somebody decided we can do that. So you now think, how do you want the ROS to be? Is it going to use Python? Is it going to use JavaScript? And that's when you come to build type. And okay, build type. I should probably increase this so you don't. Build type is C++, but we're not going to write C++. It's called ament_cmake. All right, and then you have your package. It creates with your name and some other details that even if I explain now, you're going to probably forget, because you get to know it while you use it. So this is I don't know, all this is bash, right? This is bash. This is bash. Okay, so that's the first command for creating the package. Let me write it down, because command for creating the package. All right. Okay, we've created the package, right? Now let's go and look at what does the package look like. Remember the folder we were. The folder we were was tax for submission, and then see our workspace here. You can see now there's a dog description there. That was not there before, but because we created it, it's there now. And now we have things that are inside. Things that for now we should not bother with. I explained in the last class about what a package XML is. I explained a lot of things and I mentioned a lot of things that are here, but let's just follow it slowly, because you rush and rush and things just turn south quickly. We have a source folder that's empty. We have no business with source folder for now. These are include folders, empty, nothing now, blank package. What we're going to do is we are going to something that you need to have already. It should have been installed if you did the last tutorial. If you did the last tax, you'd have had it installed. So I would assume you have it installed. So what you now do is you create a folder. You call the folder meshes. Again, you can use any name for this whatsoever, but in order to retain convention, that's why we do all this. Because if another guy names his own card and maybe somebody in Japan names it whatever it's called in Japan, it gets really messed up real quick. So we just stick by those conventions. So meshes. And then what you do is, let me write it here. Now you've created your stuff, right? Good. 4, create a new folder inside the new package you have just created. But no, while I know there are people that will just copy this without changing this dog description. So no issue. Create a new folder inside the create a new folder. Hold up. Of life calling from area. Pamela. Okay, so also checking that. Okay, so you create a new folder inside that folder you just created, inside the new package you just created. Name the folder meshes. We have that done. Now, the 5th thing you do, copy the cards in brackets STL or DAE from the initial or from your initial assigned or initial robots folder. That's the one the one they assigned to you assigned. You copy it into the meshes folder. Now, this is my own, right? No need for the final results. Even if you do copy it, it doesn't really make any difference. But I'll just copy what I need to copy. Copy. And I come here and I paste them all. Now, small, I'm building my my package. Small, we're doing ROS. Simon, what's up? Somehow I can see your hands up.
Oh, sorry about that. It was up since. That was a mistake.
Okay. So now it's all these small processes that happen along the way that makes ROS a bit tricky. And missing some of the step or doing it differently, it's not wrong, but like you might have to modify some things along the way. So we have our STL now copied, right? Now the next thing you do, 6, inspect your meshes. Again, if you have SolidWorks, Mesh Lab, someone said Fusion 3D, good choice. I 360. I don't know if it's a good choice. I've never used it, but what I've used is Mesh Lab and FreeCAD. But I hate FreeCAD. So I just stick to Mesh Lab. Where am I? Okay, inspect your meshes. So now what meshes do I have? I have DAs here. So what I'm going to do is I'll say, okay, it's not as if you are going to edit it too. Can we install both and try it? I'm inside it. Feel free, man. I recommend you fuck around to find out, like play around with everything. The only concern I have is if you are using WSL, right? If you're using Linux on WSL, I don't know. I mean, the only reason why we could run RVs was because I understand how Windows renders the I know how to switch. How do I put this? If you're running anything graphics, right? The drivers that are in use are the hardware drivers. Your actual if it's dedicated or whatever, with your actual hardware drivers that are rendering, right? But each time you run RVs or Gazebo, it's because I've switched it from the hardware to your CPU. So it's not your graphics card that is rendering, it's your rasterizer on your CPU. So there's some people that had errors and I just send them 2 lines of code and it fixed that. That's what those lines of code did. And the only why am I saying this? I'm saying this because for FreeCAD, you might have the same problem, because FreeCAD uses OpenGL on the lower level, and it might want to directly use your hardware for rendering. So if you can install FreeCAD on Linux with WSL, but to run it might crash. Another way to work around this is you install the FreeCAD or the Fusion or whatever on the Windows PC, like on actual Windows, not on the Linux, and then you can view the files because they are on the same PC. You view the files, you look at it, you inspect it, but then you use it in Ubuntu. That's the way to go about it. That's in case you ever do run into something like that. But again, it's your world, and yeah, God at the time now. The next thing that I want to inspect, right? So if I was to inspect with, I have FreeCAD, I have MeshLab. MeshLab is just the command away, MeshLab curve, and I can see what my curve looks like, right? I know this is what this looks like. I mean, I have a mental image. I can edit it, but I won't do such. I can go for the heaviest parts is the tie. Like that takes a lot of parts to render. So the tie, is it the tie? No, the trunk. The tie is pretty simple, right? So it's the trunk. You can see what I'm doing. I'm just looking around, just seeing what it looks like. Aha. This is the trunk. As you can see, all this was already done by the CAD guy, and they stripped away everything. There are no electrical components because we don't need the electrical components. We can simulate every single thing. Like we can simulate motors. We don't need all those issues. All we just need is what it looks like. So yours will not be with the dog, yours will be with the robotic arm. The problem is if I solve one robotic arm, the other robotics arm becomes easier for everybody to solve. So it's basically just try and adapt what I'm doing. Okay, so what do I do now? Okay, so you inspect your mesh, right? You inspect your mesh just to get an idea of what they look like, right? Now, if for any reason you want to tamper with the mesh, feel free. Since I go stop you, feel free. Now, the next one, please write the code for checking the mesh. And the problem is the code for checking the mesh depends on what you're using to check the mesh. I'm using MeshLab, so I can say if you are using MeshLab already, you must make sure you've installed MeshLab up here. Let me just do it again. If you are using, or if you want to use MeshLab, I think that would be the correct English. Okay, let me go to 7. Let 7 be here. If you want to use MeshLab, this is what you do. You install MeshLab, and then you do MeshLab, let's say link.dae, right? Does MeshLab work for URDF? Yes, it should. MeshLab should work for URDF. Am I sure of that? I'm about to find out. There's an easier way of doing this, but which of these parts used STL? Fanuc used STL. Fanuc, please let me not be wrong. Yeah, Fanuc used STL. Yeah. So I will simply just open another terminal, make it big, because you guys need it big to see what's going on. And I'll write MeshLab, base link STL. Yeah, it works. So yeah, mesh lab works actually. And it's pretty dope. Mesh lab works. So yeah, mesh lab and mesh lab link DAE. I mean, mesh lab. It could be link.stl. Whatever. Okay, so the eighth one is you've inspected, right? Usually at this point in time, I once inspected an STL that took 5 minutes to open, and I sent it back. I was like, nah, they have to actually reduce it. I can reduce it, but the reward for more work, or the reward for how do you say, the reward for good work done is more work. So I can, but I wasn't being paid for that. So they have a card guy that can do that too. So I just sent it back. Yeah, that's something you need to know about work culture. If you are good at something, you don't do it for free. But I mean, there are times you do it for free. But if you are good at something, you draw boundaries. Else, now they go overwork you, and it's everywhere. It's every single place. Like, and it's something I suffer a lot. So I decided, nah, I'm not suffering that again. So I just send it back. Okay. So number 8, what are we doing? We've inspected the mesh. The mesh looks okay. You now create a folder called URDF in your package folder. This is where things get tricky, because if you create, remember, if you are viewing your mesh lab, let's say you just did mesh lab now, by default, you will be, this is where your meshes are. If you're here viewing it, by default, you will be here. And if you create a URDF inside here, work done equals 0. Again, you can still create a URDF inside here and do what I want to tell you to do. You will just have to follow it mentally, and you've entered an alternate path. If I see somebody that creates a URDF here and it actually works, I would give him accolades, because it's you actually twisted the system and it worked. But I will not recommend it, because if you now send your folder outside, your project outside for someone, and then they can't see the URDF file where they're supposed to see the URDF file, it just creates unnecessary stress. So this is why we're creating the URDF file. So you can see we have URDF, we have mesh, we have source. So you can see all the main files, folders or directories, they're all outside. So that's what I mean. Package folder, this stuff, this folder here is the package folder, or you can call it workspace, package folder, or workspace folder, or workspace. No, it's not a workspace folder, it's not a workspace folder, because this is the workspace folder, and then this is the package. Yeah. So this is what we have. What do we do next? We build the package. No, we don't build. Now this is where we actually start the URDF. Now I would do this here. Start the, I can make it. Please go back with the navigation. What navigation? Yeah, to speak to me.
Yes, I want to see the hierarchy, the file structure. You were saying something about the package folder, the dog folder, and then I
Let me
didn't
show
see
you.
the file structure.
Let me show you
Yes.
from here. Let me show you from here. This is a way to easily see it. Let's make this very big, like ridiculously big. Then let me close this and let me take this smaller. Mess up. Okay, either ways. You can see this folder here. This is the folder that you copied from my repository. This folder has the final result and everything, but this is not the folder you work with. You create your workspace. In the workspace folder, you can see there's another folder called doc description. And in that doc description, you have the include, you have the mesh, you have the URDF. If you create this URDF inside this mesh, like maybe because when you inspect your mesh, you are going to be inside this mesh folder. So if you create that URDF like this, it's going to give you issues, except you play around with your CMake list and your package XML, but that's a bit too complex. So just follow the norm and just create your URDF outside together with where your mesh is. Yeah. So that's the idea I was trying to pass across. That's the idea I was trying to pass across. Path. Yeah. Latifa, what about paths? I mean, it's called paths, but like, I don't know what you're trying to say exactly.
I was just trying to add to what CC asked.
Okay.
I think he was trying to say path.
Yeah, I believe he was trying to say paths. Okay, so what am I supposed to do now? Okay, yeah, URDF. So you open your workspace, you open your package, we open this file, call it code. Anyhow you want to open it in your VS Code, or anyhow you want to do it, fine. Someone said you can open VS Code from WSL. That was impressive. It's not recommended, but if you can get it done, good. Now you create your folder called your file called dog.urdf, and this is where life gets tricky. First of all, I would recommend you install two things. There are some extensions that will help your life, which is do I have to write it out? I can probably just send the pictures. I can send the pictures. This, and let me see if I can embed it here. Ah, yeah, I can. Ah, smart. And the idea visualizer. I don't have this one. I don't know how that one works actually. What I have is this and this. What I have is this and this. So I'll put that here. Go down. So I'll say install the following extensions. Oh, okay. And what do I want? What extensions do I have for us? I have this dev kit. This is deprecated. I have this. You know, you could just install some couple of listen for us. This is all I have for us actually. It just helps you with syntax highlights, maybe autocomplete. No, it helps autocomplete too. So install the following extensions. Install the following extensions. Life will be easy. Life will be easier. All right. So let's assume we've installed the extensions. It's pretty straightforward. What do we do now? We're on this code. Now, a URDF, the first thing you should note in creating, or like let's say in coding or in writing a URDF, all of the robots, right, Oh no, everything in the URDF must be enclosed in a robot tag. What is a tag? A tag is anything that starts with ankle. I can see it has suggested robots for me already. If right ankle, it suggests robots for you. And it tries to give some autocomplete. But I don't use autocomplete because it will quickly fill up this place for us. So what we can do is we can is there a way to turn off autocomplete? I mean, there is a way to, like,
Yeah, you can use the GitHub icon and disable it for some minutes.
yeah, I've never had a reason to turn off autocomplete. GitHub icon.
Yeah, bottom right.
I mean, I can see the GitHub icon, but like,
I think
I
it's
could just
Copilot.
I could
Turn
just
off the
ignore it.
Copilot. Yeah.
This looks so. I've never had to turn off anything. Okay, yeah. Hide completion for 5 minutes. And that makes sense. But this stuff has like my metrics, so chat messages. I know this is like how much you talk with Copilot. I hate talking with. I feel it just makes noise for me. Like, okay, so robots, and you can see now there are suggestions, not autocomplete, right? So if you take the first suggestion, it does something like this for you. But let's assume we don't know anything. The first thing you do is robots, and then you give the robot a name. And that name now can be anything, frankly. It must not be your package name, because you can have multiple robots in one. And I was writing a URDF file word for word because I thought VS Code did not have user code support. See, writing a URDF file word for word teaches you a lot. The first URDF file I wrote was word for word. The first set of URDF files I wrote, because it just helps you understand. Like, if you always autocomplete for it, then imagine you have to edit something on the spot and you don't have autocomplete. You know how it goes basically. So robot name, I'm like dog. Okay, so what do? I briefly close it, right? And then I open another, like an ending one called robots, and I close it back. So that's basically how this works. Now, everything you write will be inside this robot tag. Let me put that down here. So everything you write is inside the robot tag. The next thing you might want to think of is, okay, links. How does when everything is a link for the robots? If it's two robot link, you have like the arm, you have the hand. It's a link. Even the dog, the leg is a link, the body is a link, the tie, everything, you consider it link. But in this case, you might want to swing back to your description and see, okay, I have calves, I have depth, I have hips, I have thighs, I have all these things. The first thing you need to do is to determine which is your base link, right? And what I can do is I can create another link. Again, it has suggestions. If you don't want to use those suggestions, which, I mean, regardless of whether you are using it or not, I would advise you that you should come here, ROS URDF, And finally, a coder can be familiar. Now, so web dev don't talk. Admit all. URDF, the XML is not even code to start with. It's a markup language. Let me not even enter you people. HTML is not even code. I mean, following the strict definition of programming. Unprecedented attack. Okay, so this page. I'm sorry, I didn't mean any harm. This page has every single thing you can think of. The problem is in reading the page, because the first time I opened this page, I think it was in January this year. I opened it at one lab, like, where I was in my internship. It was terrible, but it has just everything you need. It's difficult to read, but by the time we go over what we are doing, you understand what we are trying to say. So I'll put it this way: for every link you define, we've called this our link. The name of our link, what do we call it? I want to call it base link. Auto this thing down on. Don't rush, make many recommendation. But actually, I work with auto this thing a lot because it's faster. Okay, so I'm still for 5 minutes. I'll take this out. I would call this link base link. Now, you can try not calling it base link and find out what will happen. Now, for your link, you need to define 3 things: visual, which is how you see the link. What else is it? Collision. Yeah, collision, right? Visual, collision, and then
I think you
the
said
third one,
inertia.
inertia. Yeah. So over here we see visual. We see all these are part of visual. I know this stuff is pretty messy, and probably the reason why it's not the best of tutorials. YouTube would also work for YouTube, but they mostly advise you to like get comfortable reading all these things. So okay, so visual, you have collision, and after collision, inertia. So there are the 3 major things. But for now, we're sticking with only visual, because visually we want to look at it first of all. That's the first thing. We want to be able to see the robots, right? We want to look at it. So we stick with visual. What we can do is we can specify geometry. Geometry is what you want it to look like, per se. And from the examples they have here, you can hit geometry, and I don't know, it's giving me an extra line. So see, basically it's just the geometry, and then you close the geometry. For every tag you open, you close the tag. So I want to use box. So I open a tag for box. This is box. The box needs to have some size. I can have 1, 1, 1, and this is square, right? This is what I have for me. Yeah, this is what we have. Let's just assume this is what we have. What I can do is I can come back here to your workspace. This is your workspace. You come into your workspace. This is your package. What I'm about to do, don't do it inside the package. Again, nothing stops you. It's computer. You can do it. It might work. It might fail. You might find your way around it, but do it outside here. The robot closing is different from the rest closing. Yeah. No, it's not. It's not. Oh, sorry. Yeah, it is. It is actually. It's not supposed to be. I just basically skipped. Because if we look at the documentation, let me go back here. If we look at the documentation, it is yeah, the same thing. Yeah, so that was my blunder. Okay. So what we do is we will go here, open. Now, if you remember, we've not done anything about Qualcomm build though. We haven't done Qualcomm build since. We just created the package. So that package we created, we are going to build it. We're going to build the package. So I will go with Qualcomm. And that thing you can do before you build your package, you can list it to see if there's any package there to start with. And then there is doc description. So Qualcomm build. And then we have our package. And then you source install setup .bash. And then we've sourced it. Then remember, we've edited our XML, we've edited our URDF, so we should be able to see something. Let me update the guide. Okay, so after installing this, guide to build your URDF is in the recording. Makes life easier. What next? What have I done so far? Okay, build your package from the workspace folder, not inside the package folder. It would work, but it gets messed up, like very messy. And how do you build that? We use bash. Don't copy you won't even see the bash stuff, don't worry. Qualcomm build. Qualcomm build symbolic link install. The reason why we do that is to reduce the amount of space the build packages take. I didn't do it with mine, but if I was to do it with mine to give me the same thing, I would first of all have to remove recursive, the build folder that is there. I would remove the install, I'll remove the log, and then I would now do Qualcomm. No, look at it. ls, it's just the doc description that is there, and then I'll do Qualcomm build symbolic link. Symbolic linking is a way to just think of it as your exe on your desktop. You have your shortcuts on your desktop, right? That shortcut is not really the app. The app is somewhere else, and that desktop shortcut just links it to the app. So instead of having the app everywhere, you can just create shortcuts. So that's what symbolic link normally do. So yeah, we have built it. We have few warnings, but it's live. It didn't fail. It's just warnings, but we're good. So we source again. Source install setup.bash. Okay. So after you build, you source. And after you build, you should source. And then I'll just have this from here. Put this here. And then I do source install setup.bash. Okay. Now, what do we do now? At this point, this is where, let's assume we've made significant change on our URDF. Right now, our URDF, if you remember, is just a box that is there. Your URDF as we speak is just a box. How do I know it's just a box? Let me take it back to the URDF. All I did was dog base link box. A box with X 1 meter, length of 1, Y of 1 meter, Z of 1 meter. So what I'll do now is ROS2 launch URDF tutorial. Now there's a folder called URDF tutorial that we installed for the last tax. There's a package called that. So if you have an error running this, you probably have not done tax 3. So ROS2 launch URDF tutorial display launch py and model. Model is where you now tell it where your URDF is. So what are we doing with this? We're telling ROS to launch from the URDF tutorial package. The URDF tutorial package is not our package. It's a completely different package that we install to help us launch RVs. So we say, okay, ROS2 launch that package URDF to help us view our URDF. Display.launch.py is a launch file. What a launch file do, it opens up RVs with a lot of commands that we might or might not go into in the future, but understand what exactly the command is doing. Now, after these 4 points, after ROS launch, URDF tutorial display.launch.py, you specify your model. The model is the URDF. So now what's the path to your model? If I should make this a bit shorter so that we have model on one line, which is the last line, your model is present working directory, PWD, that's where you are now. And right now we're in the workspace, /dog description. Inside the dog description, our URDF is in the URDF file, dog. So, may we not get lost when we do this. Let me add that real quick to the after done. Now, if you want to visualize in RVs, this is what you use. And I'm going to wait for people that copy it exactly to come in. Okay. What
I
do
have
we
a
do
question.
now? Yeah, speak to me.
Yeah, you said the box was 1 meter by 1 meter. Is that the default? Is there a way to change it?
Yeah, sure. I mean, you can make it 1.5 meter. You can make it 2 meter. I mean, you can make it 4 meter. You can make it 0.1. But these units are metric units.
Okay, so the default units cannot be changed.
Nah, you just have to convert it. You just have to convert it. Sorry for the Americans using what are they the imperial what, but you just have to convert it to metrics. Everything works here in metrics. But let's stick with our box because we want to see our box. All right. So so many terminals at the same time. All right. So we run this now, and it opens. But then I can't see my box. I can't see my box because I didn't define where the box is. Right. You've specified the size of the box, but you've not specified where the box should be. So it doesn't even know where to put the box. So your box could literally be anywhere in space-time continuum. Like, well, okay, let's rectify that issue. Let's specify origin. Origin. Visual first. Visual. Auto command. I mean, what they call it? Auto this thing is back. I believe I can delay it for like longer. Isn't there a way to like delay it for longer? Okay, I can do this. Okay. So link. I have to specify virtual and I have to specify origin. visual rather, visual, and I will close it. I'll close it. Okay. Does this work? Time for experiments. Yeah, it works. It actually works. Okay. So we have a box that is at the center of everything, right? I mean, good to know. Good to know. All right. Now that we know how to run our RVs, we know how to get things going. Let's work on the URDF, because that's what the problem is. Is URDF sequential? I want to believe what you're talking about is procedural. Like you're asking. Okay, explain what you mean. Let's be sure we're on the same page.
I mean, we wanted to define the origin first. Then you said, no, let's define the visual.
Yeah. So what do you mean by sequential? Like I'm trying to understand the use of the word sequential. Let me fully understand what you mean. How about Chief? I can't hear you. Are you talking?
First.
Network is bad. Okay, so I want to guess what he was asking. We didn't define this visual, so without defining visual, it's not going to show. For origin, if you don't define, let me show you something else. If I should create another link, let's just copy the previous link we have, since we already know how links work. If I should create another link and say I call it, again, this now is complicated because we have to now specify joints. So I call it link 1, and then say I create a joint.
Does it fall in that sequence?
I create a joint. Okay, see, just type. I don't know if you can type your question. Probably to be easier. I'm coming. I'll explain all of this. I just want to forget about this joint thing that I'm doing. I want to just show you something like what happens when you don't specify origins. Yeah, I can see your hand raised. Speak to me.
All right, it call came while I was here.
So
I was asking earlier we were trying to visualize, right? We said you play origin first, then you said no, let's visualize, let's place visuals first.
So what happened was I was thinking out loud, right? I wasn't really explaining, but let me explain what happened. It didn't show, right? First of all, it didn't show. So what went to my head first was origin, but then I went to the URDF and I saw that we skipped to add the visual tag. So there's actually visual is like what it sees, so it can't see anything, right? So even if we put a geometry that there's a box there, it doesn't know if you're referring to that as that's what I'm saying. So when I came back and I was like, there's actually no visual, so it's probably visual, right? Meaning it wasn't the fact that there is no origin, because now it worked. But what it did was it fixed it to 0, 0, 0. That's the origin of 3D space. So what I want to also show now is if we create another link, right? Let's say another link that's smaller in one of the dimensions but longer in another dimension, so that we can see it. let's say 0 points, probably 0 points 0.5, right? So you see these two distinct things. Since there is no origin, it should still show the two links, but it should center link 1 at 0, 0, 0, the same way it did for the base link. That's what I want to confirm. So yeah, that's what happens. It centers it at the base link. But there's like some issues here with these transforms, blah blah blah. But that's not our problem for now. That's not a problem for now. So kill this. Also kill this link. We have two links now. Sorry, we have one link, which is our base link. I can now replace this link. You know, we're using a box. The idea is let's not use box or stick or whatever. So now we use what is called mesh. Sorry, just making it clean. And I delete this. Now we use what is called mesh. Now when you want to mesh, you provide the file name, that's where your mesh is, and you provide the scale, right? Because sometimes your mesh, you might want it to be smaller in URDF, you want it to be bigger, things are not really scaling up, whatever it is. But yeah, now for the file part, I want to specify package. There's a way to call the package so that we don't have to be using file paths. So I want to believe it's in the URDF. Sorry, it's in the package. What's our package name? Dog description. Dog description. Where is it? It is in meshes. And base link. Now, before you create your base link, you think to yourself, what do you want to be your base? I've made the whole thought process easier for a robotic arm. The link 1 or the link 0 will be your base link, or the link the specified base link. It's easy for you. But now for the dog, I would have to consider some things. My base link, I want it to be my body, like the trunk, if that's what it's called. Hold up. Yeah, the trunk. That's what I want it to be. But there's a consequence for using that, which I'm not going to discuss now. That's not the best option, but that is what I want to use now. So I would call it my trunk.dae, and it's the scale that I'll still leave it as is. And now let's see if we have something good. Now we don't have something good, and there's a reason why. Aha! The reason why is mesh was specified but could not be parsed. Again, you go read log. You read log and you'll be happy. This is the error. There's supposed to be 1.0. You scale it in 3D. You don't scale it in only 1D. Like the scale works by transforming in 3D to make it longer, wider, or like taller. So 3D. And we go again. Okay. It's a different error. We still can't see it, but it's a different error. Now, what's the error? The error is saying that unable to open the package, we cannot load the resource. Yada 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 yada. Why is that the case? Now, let me first add this to your format. Let me first add this to here. I would say this is in bash with XML work. XML and I will call this hints, like formats or something. I know I'm facing an error, but let me just put this here first. I would call this formats for URDF. Okay. Now, our error is coming from our CMake. There's a line that we are supposed to call include destination. How is that syntax written? Hold up. This is when I go back to previous code that I have written. I mean, there's an easier way to do this. You can just probably search for it. Well, I like reinforcement learning. Okay. So it wasn't included in the first place, it was installed. Now, what exactly are we doing? We are installing. I realize this is going to be too complicated to explain. So I know there was somebody, I think it was Emeka that was trying to find out where the ROS file is and all that whole drama that happened on the group chat. What we are doing basically is we are taking our mesh and our URDF, we are installing it in this destination share project name. It's a long story, but this is basically putting it in ROS internal so that we can use that URDF tutorial URDF tutorial package to visualize it. So we make change to our CMake, meaning we build again. It's just the rule of thumb. I can build in the terminal here. Ctrl+Shift+P terminal. Just create a terminal here. I'll on build ls. Let me show. Nope, I'm not in the right directory, so I'm here. Good. And then cocon build symbolic link install. Can you imagine? Oh yeah, I'm using double O for my cocon. Sorry. Okay, so we're done building. Now let's go back to our. Let's go back and see if that solves our problem. Hopefully it does. Good, it does actually. And now you can see the robot here. Please, how many more minutes to the end of class? Estimated? I don't know. I do not know. But if you read my message, we're supposed to meet for all these live coding sessions today, tomorrow, Friday, and maybe Saturday, right? So you can always watch the recording actually, because I don't think class is ending anytime soon. At least let's do something. Okay, so we have these parts here, right? Good. Another thing that I want to do, well, what I advise you to do is, after bringing in one part, bring in other parts too. Like 9 p.m. Is it not 9 p.m. already? Okay, it's 9 p.m. my time. Yeah. 9 p.m. Before 9 p.m. we should be done, because we've already covered it's just to copy some more URDFs and so before 9 p.m. Okay, so what we are going to do now is, or what I advise, what's up, bro? I can see your hands up.
When we use the mesh tag, right, we're using that package. We're using it as a package and not the path itself. That's why we had to go back and write to that settings file again.
Yes.
That's important.
Yes.
Yes. What if we use the direct file path? Will it work, and will we still need to write it?
Now you will not need to write it too. You will not need to write it. But by the time you send it to another person's laptop, the computers are dumb. It will still try and read the direct part from your laptop, and it won't work on his, because as you can tell, he has different folder, he has different file name. You get. So the idea of ROS is, again, the exact problem ROS is trying to solve is the problem you are introducing by using directories. So that's why I decided to use, okay, let's use package, since the package will be the same name on every single PC. So everybody can use it. That's the idea. The idea of ROS was to like bring everybody together, right? Alpha Olamide.
Yeah, so sorry, please, you can correct me if I'm wrong. So what we're doing with what we're using URDF to do is we are using it to assemble the scattered
But now
parts.
wisdom be that. Now wisdom, like better wisdom. Now, as you can see, that's exact name of the repo. Operation Industrial Virtual Assembly. That's what we are doing. Because the card does not work. You can't just carry full card and do simulation with it in robotics. It doesn't work like that. Everything has to be in our own language. So this alone is a tax, at times a day or two. But if it takes you a day or two, you need to actually learn how to be faster, because a day or two is a bit too much. But for starts, a day or two. So yeah, that's what we're doing. That's the first step. Else you're going to keep on using sticks. Okay, so I need to create another link. Now let me bring in the dog. Sorry, let's say, which other link should I bring in? Let me bring in the tie, because the tie is close to the body, right? The trunk, the tie is close to the body. So file mesh, all I need to do is change this to tie, but it's going to fail, and it's a kind of failure where, I mean, what did we really expect when we're doing it? So we kill, we open, and it fails. It fails because for each link you specify, you need to specify a joint. You need to specify a joint. There must be a joint. And we come down. The way I prefer doing mine, link joints. Some people specify all the links, right? And after specifying all the links, they come back to specify the joints. So you would have link everywhere and then joint at the bottom. Some people do the weirdest one I've seen is link, joint, and then link. That was very, very weird, because like it made you understand that the URDF does not read the file like top to bottom. It's kind of takes in everything and arranges it. So link joint link, or link joint, or maybe if you're probably a psychopath, you can put the joint at the top and then the link at the bottom. But I don't know how your head is going to process having the links at the top or at the bottom. But again, yeah, link joint link does not still make sense to me, because why? I have a C++ kind of head where you specify, you define everything before you use it. So when you do link joint link, in the joint you are using the link that is being defined after. Let me show you something quickly. If I set up a joint, right? This is what a joint looks like. A joint has origin, parent, and child. You see this parent and child? In here, the parent is for example, if you have base link and your first link, the parent will be the base link. So if you now put the parent as base link, you now put the child as what are we working with? Say Taiwan. Taiwan. And then this is Taiwan. This makes more sense to me, because I have defined the Taiwan here, and I'm using it here. But again, this is not programming. We are just writing things. So that's why you are allowed to put the joints here, because now you can see the joint is now, this is link joint link, and they give me a headache, because why am I defining the tie after the link? So even as I'm saying it, I feel it's not supposed to work, but it works. It actually works. But that's what happens when your head is like I don't know, C++ ish. So what else am I thinking of? Okay, yeah. So we have a joint, but this will not work again because there are some things we are missing, which we will now come to. So just proof of concept. Sometimes when things doesn't work, I'm happy, because if it works, then I get scared. Like, why did it work? Oh, it worked. It actually, okay, no, it didn't work. 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 See, there's error. There's actually an error. Transform. It didn't work. Yeah, it didn't work. It didn't work. Okay, so yeah, this is a lot of recursive error. So I mean, we now kill it. Now let's fix it. Our issue, first of all, is we don't even have origins. That is, we don't even have origins for the link. Remember, frames. Let me run it again to show something. Remember when I had to define frames and explain frames and talk about frames. There's supposed to be frames, but there are no frames. Is there way I can make this? I can make RVs bigger. I mean, I can do this, but it doesn't work. Okay. Either ways, now we have to create those frames, because see, you can actually see, you can create a URDF without visual but with frames, and it will work. The math does not care about the visual. That's why we have headless machines to start with, machines that run without GUI. We don't really need to see per se, provided the math is running in the background. No one. So it doesn't work now when you have the visual without the frames. But if it's the frames without the visual, it can compute, it can do some math, it can even probably simulate. The visual is not for the PC. The visual is for you. It will do whatever I want to do regardless of visual. So origin. Where do I specify origin? Collision? No. Geometry. I think there's an extra tag for origin. So I quickly run down here, and I see origin. Good. There's a tag for origin, and I basically compare, and I'll be like, okay, origin. Now origin has two parts. We have XYZ, and then we have RPY. RPY is roll, pitch, yaw. RPY is like rotation, but I would come to that. So on XYZ, we have this. On RPY, we have this. Okay. Now, origin 0, 0, 0. We all know what 0, 0, 0 means. Rotation is like how are you? Is there any rotation around X, Y, or Z? No, there's no rotation for now. So let's say we have origin here. Now let's run. There's an error, and these errors these are usually irritating, because you have to check line 5, column 12, but this is not always accurate. There's no close to the origin. That's why I'm supposed to close the origin with this. It's either this. I know somebody will say this is a different closure, but if it works, it worked. But we still have the same problem, because we don't have everything fully defined. So let me have a case where I remove all of this. Okay, so I have just this now. Do I, sorry, where am I? Okay, so now let me run again. Okay, now we have this. But I don't know why my, okay, I know why. I know why. I know why this origin is not showing, because this is base link. So I can do something like this. Should I fix this? No. Let me just have this. All right, okay.
Sorry, Mr. Bakel. Somebody says he's trying to join the call.
Someone is trying to join. Oh, Saeed. Thank you very much. Saeed. Okay. Where was I? Okay, then let me specify origin for this. Since we have two links, so let me specify the origin for this one. Specify the origin for this. Again, I'm still putting it at the center. I'm still putting it at 000 because I want to see what it would look like. It's just good practice to start from 000 and then you can work your way up. I'll show you what we are working our way up for. So I run again, and we are still having errors. And what's our error this time? That there is no transformation from Taiwan to the base link. And why is that the case? Before some nights, it's gonna be years and anyways. So different name is link 1, link 2, visuals. Have my size scaled up. Am I missing anything? I mean, I can put this at 1 and maybe put this at 1. Let's see. And put this at 1. I can put this at 1, 1, 1. But I'm unsure if this would solve the problem. It's not like a magic switch. This time I didn't even sure. Okay, I'm definitely missing something. Let me see. Here's the previous URDF that I have. I have my base link, I have my visual, I have my origin, I have my mesh. That's good enough. We have base link, we have fixed. Can probably try fixed. But if I have fixed, a lot of things would go. This would go, and probably axis would go because there's no rotation. So there are times you skip something little, there are times things doesn't just work. But yeah, okay, that worked. That worked. That worked for a very annoying reason. It worked for a very annoying reason, and I know that, and I know why. I know why it works. Okay, so I briefly had to go and spy my initial working, and this is the thing. Your base link should not be the dog. I mean, I said that when I started that it's not the right choice, but again, I like finding out things on the go. So the base link should not be the body of the dog, because that base link will not be able to move. Right? That's why it's called base link in the first place. So what I am supposed to do is I would create an actual base link, just something small, an actual base link, and I would have that base link to be not a mesh, just something subtle. I can have a box with maybe 0.1. Okay, I can have a box with 0.01, just something a bit almost invincible. The other ways to go around these issues, though, and Zacro helps us do all of these, but since we are dealing with links first, let's work what we have. So we learn the basics. And then I can now have my tie 1. I would call this tie 2 now, since now we have 2 ties. We'll still put this on 0. I would still put this on 0. 0, 0, 0 works pretty well. That was not the problem to start with. I'm going to have tie, but let it be tie mirror, because I have a tie mirror. The reason why I have a tie mirror is because like the dog has 2 legs, one on this side, one on this side, like 4, 1, 1, and then 1, 1. So there's a mirror somewhere. The provider will be the mirror. Mirror.dae. So I have the mirror, and okay. Now I have my joints. My joint is going to be, let me call the first joint to be trunk to Taiwan. Trunk to Taiwan. No, the first should be base, because I have a base link. Base link to trunk. Fixed and something like this. Okay, so we have the base link, and sorry, we have trunk, and then this goes as trunk. Okay, so we have base link, we have trunk, we have tie 2, we have something like this. Let me take this out, because we only have 2 links and 1 joint, and this is like a quick fix. The quick fix that ran into an error. What's the error? Waiting for this to be published. It didn't say anything in the error, actually. I just somehow know that that's what it's supposed to be. Okay, so now we have our dog up here because of how we define the transforms. We have our dog up here. Okay. I can add my legs to it now. But let me put this at 0. 0, 0, 0. If you have everything at 0, it's easier to like position it. So there's an easier way now to run something. Okay, so now we have everything here. So you can see we have the transform, we have everything sorted out, at least for now. So it's a bit easier to continue working. The next thing we'll now add is we can add the second link, which is the tie. We can add tie 1. We can have this to tie, and then we can now have another joint, and this joint would be between the, let's call it base, no, not base, trunk, because now we're using the trunk, and then the trunk to Taiwan. Trunk to Taiwan. It could be fixed for now, since I'm just experimenting. So from here to Tai, between this and Taiwan. Taiwan. Okay. Then we pray. All right. So now we have this here. We have this here, right? What I can do now is, I need some offsets. But I mean, for now, everything is showing. I can measure from this point, to this point. This is 0.2 meters. So I can offset by 0.3 meters. I know it's a bit tiny, but I'll explain what I'm doing. So I can offset by 0.3 meters, meaning I would offset it in what direction? In the y direction. Green is y direction. So 0.3 meters. We're going to have another class to explain this properly. I can assume that this is very tricky. So I'll have this at 0.3 meters. This link to Taiwan. And if I should run this again, aha, but now it's too far. Again, measurement is off. Now this is where you would now probably want to use, the CAD software to actually measure where distance from where to where. 0.15. There's a more efficient way to do this, well, 225 because 0.15, 1 at this point, 5 at this point. So this is it. Yep, that's it. So we have that leg there. It's almost there, but you can see now that there's these holes. The one for the arm is not this technical. For this one, I would have to now go to the 3D card to actually measure to know what number I'm going to put where. But for now, this is like the whole mental flow of things. Let me probably take. Do we still have much time? We have some time. Oh, okay. So yeah, and that thing that we can also do is we can also view the URDF from here. We can preview the URDF here. The only problem is if the URDF is too large, it might lag and take a long time. And then you see it's trying to like build up. So if your URDF is small, you have no problem. But the trunk URDF is like 64 megabytes. So that's too large. Other parts are like maybe 2 megabytes, something like that. And then you see it freezes. And then you can keep waiting. And so you have something like that. Yeah. So let me close this. This is why I don't visualize here, but you can visualize some other things here too. If you have, let me open this in. This is one of the solved examples already. I can preview the URDF here. It'll take a while, but it's going to come up. Yeah, generally speaking, it's slow, but it works. And that way you don't have to be running the command to close and open it, but it comes with its own cost, its own overhead, which is it's pretty slow to show up. Now we have it here. Yeah, what's up? We have something.
I have questions.
Yeah.
And so, first of all, how did you get the file name for the meshes?
How did I get
The file name for the meshes.
file name? Oh, the file name. Oh, okay. I explained that we have to use paths to the file, but instead of using absolute paths, we are using package names. Like, let me show you. I have to iterate over so many of these. Okay. So I believe you're asking for this, right?
Yes.
These file names. Okay, so we can use the I'll answer a question shortly. We can use the what do you call it? What do you call it? Absolute parts. You know how parts works. You will do dog description / messages for you can use the absolute parts. But again, the problem with using absolute parts is that I explained that if you put it on someone else's PC, it's not going to work. So what we do is you do package. Remember, you created a package and you built a package. So that package, then the name of the package. This is the name of the package, description, dog description. And that dog description, now you go to these meshes. Remember, you already copied your mesh into this folder. So you just select which one you're referring to. Now, you want one to move. Remember, we've already done our leg. So let's make our leg. This is where you change it. You make the leg revolute. Now for revolute, you have to do a lot of things for revolute, actually. A whole lot of things for revolute. You specify the axis and the limit. And right now, I don't want any limits. I don't want any limits. I don't. Does this work? If I have a limit of 0, 0, I feel that's problematic. Can I just skip it? Or I can have negative 3.5, negative 3.14 for pi. No, for 2 pi. No pi. Pi. Okay. I can have 3.14 for pi. All these are a bit irrelevant. I can put this at 0. I can put my velocity at 0, or maybe 100. Oh, sorry, 0. Okay. I just want to show you how you make it rotate. And what do we now do? Well, we now run it and hope it works. It should work if I've not skipped anything. Okay, it works. And now you see you have 2 axes, right? And then let me show you. Let me make it bigger. So we have this, and now we have our controller here, and then we can move it because we made it revolute, not fixed, so we can move it actually. And then sorry, what's up?
So did you create a launch file to launch this, or like what
That's
file are we
nice.
going to launch it?
You know about launch files. I could create a launch file, but I'd rather not, because there's already a launch file I can use. There's a launch file in URDF tutorial. Remember, this is the command we're using to launch it. Let me show you something. We are using ROS2 launch. Now, technically, if I wrote a launch file myself, I will now write dog description and then the launch file, maybe launch.py, whatever, the name of my launch file. But I didn't write one, because if I write one, I have to teach you how to write one. So we can start by using what's already available before we like narrow things down. And there's a launch file somewhere. Where is that launch file? That launch file is in other locations. It's in my computer. It's in opt. Where is the launch file? It's in ROS, it's in Humble, it's probably in Share. It's in Share. Now in Share, it is all the way down here in this pretty folder. Launch. This is the file I'm using. So this is the launch file I'm using. Why? Because I can literally just copy this and make my own launch file. But I mean, why do that when you can just reuse? I mean, ROS allows you to reuse it. So launch URDF tutorial. As you can see, I am now using another package called URDF tutorial. Look at it, URDF tutorial down there. That's the package. And in that package, I'm using their launch file, which is display. So if I do display.launch, and then all I need to do now is to give it my model. Why? Because the launch file accepts my model. So this is it. It says, okay, add action model, and then the path to the model. It accepts my model, so I can just do that instead of having to write mine afresh. And then what's my model? My model is my present work directory, dog description, URDF dog. And then we have our path that is going to take a while because it's too heavy. Now, I tried as much as possible. That's why I didn't give anybody this one. I didn't give anybody this one because this is 64 megabytes of STL, and it is just. I mean, I know how insane my PC is like for spec, and it's still slow, so it would be shitty to work with. Okay, so right now you won't be able to do anything. No, sorry, that's not why I said it, or that's not how I was supposed to say it. Right now you won't be able to achieve everything. I think achieve is the word. You'll be able to achieve everything. You might. I mean, there's some people that might even do and even overdo. I dey fear on disease. So what you can do is, regardless of where you stop, see, even if now one folder you create, regardless of what you do, right, I encourage you to push it. And there's a reason why I'm saying that. It must not be all perfect yet, right? You must not say, okay, you wait till it's perfect before you push it. No, push it. Because like, that's how you just have many projects that just die on your local disks. So let's go back to the assignments, the assignments folder. Where's the assignments folder? I can just search for it. I can search for it, but again, I've already started looking for it, so I don't search for it. Okay. Now, this is the assignment folder, this is the submission, this is the workspace. And so far, so good. You will now have to push your code. Now, when you're pushing your code, be very careful not to push the whole workspace. Nobody wants your entire workspace on, like, nobody cares about having your build everywhere. We don't need your build. This is just a lot of, you're just wasting space. So you are going to create, first of all, you are only pushing your description, which is, this is the actual package. This is the only thing you're pushing. So you are going to now open this in your terminal, or however you know how to push. Kindly send link to the repo where it's going. No, Said, don't worry. Don't worry. Please write that in the steps. What should I write in the steps? How to clone, like how to create your repository. I don't even know, Seth, where am I in the steps? I stopped updating the steps at some point. Okay, this is the format for the URDF. Okay, so I let me add the format for the joint. So this is what worked for us. So far, so good. So it's just for you to just adapt this to yours. The circle of life. and then I will just put this at the bottom. Okay, so this is just formats. This is example of joints. Let me have that here. Example of how to use joints. Yeah, so autocomplete would really even help you like very, very fast, but it's good to know the in and outs, because if something breaks, you just be there. So notes, regardless of the amount of progress you make, small or to what's up?
Yes, I want to know, is it the limit star that creates the slider? I mean, that slider for the rotation.
You're asking where the slider comes out from.
Yes.
Good. Now, your question now is beyond this whole, because now the internals you just want open. Where does slider come out from? Slider comes out from the launch file we are using. And where is the launch file? Have I closed that in? I've closed that in. So you go and send me on errand. Not good if I launch file. Okay, that's what we live for. So we there's an easier way to do this.
Remember, we didn't run the launch file before. We didn't run the launch file. We're still working. We ran the launch file.
Yes, now. What are you referring to? Wait, I'm coming. Is it not? Hold on. Is it not that slider that if you turn it, the leg of the robot rotates?
Yes, the leg of the robot rotates. Yes, that's
Yes,
slider.
it's the launch now. Like, it's when we run this now. It's when we run this that this thing pops up and this thing comes up now.
Okay.
Yeah. It's when you run it. If I kill this process, everything goes. It's actually the launch file. Launch file it's in opt, it's in ROS, it's in humble. I think this is an easier way to get there. It's in share, it's in URDF tutorial. Instead of clicking and finding and clicking, it's in launch, it's in display. So your slider is coming from here, this particular line. If for some reasons you kill the line, like you temporarily kill the line, the slider will not show. Should I put that to the test? Yes. I'm taking it out. Do I have rights permission? I don't have rights permission. I don't have rights permission. But again, it's the computer and I'm a god in the terminal, so I will give myself right permission. Sudo. Good. And now they're telling me warning. No, I make my choices here. So I would give this hash and I will give this hash. So two things will happen. It's either we crash or we don't see the slider. But it's most likely that we don't see the slider. So I'll kill this and then we run the ROS launch. Crash. Okay, I skipped a line. And then we go again. GUI does not exist. It's going to be like really messed up. But now I'm interested in finding out. Okay, it's passing GUI here. That's where the problem is. It's passing GUI. So I can still kill this line. Alpha, what's up?
So I noticed at the beginning of the session, right, we were using C++, right? But I noticed that the file for this slider is written in Python.
That's the power of ROS. ROS, you can combine anything on the same time. The package is different from.
Okay.
Yeah, the package is different from. It's different from. It's different from every other thing. Okay, so it's going to take more than just. It's going to take more than just one effort to. It's going to take more than just looking at this, because this is another man's code that Curiosity has decided to mess up, but we have it launched. The GUI is still there. The GUI is still there. It's still there. There's a second line spinning up the GUI. But anyways, this is where we go to. This is where we go to change these things. URDF, RBC URDF. I mean, it's launching, but it's still launching the. It's still launching that. And okay, I'll do it this way. I will permit it to pass. Right. Sorry, this isn't really part of the class. This is just how we get to know weird stuff that we're not supposed to know. I will. Okay, that's for back compatibility. I would permit the arguments to fly. I'll permit the arguments to fly, but I would pass false. I'll pass false here. So the argument flies, but we return false. And if it works, no GUI, no slider. So you can see now we don't have the slider. Yeah. So that's how it works. Apparently it's not my code. So apparently there is another way to, even if I kill the slider, it still like springs up the slider. But like there's a proper way to do it, and that's what I had to find out. So let me change that back before I forget that I did that. So yeah, so you can do anything you want. Just know how to fix it back when you're doing it. So yeah, we have our slider back. Okay, so Chuko has carried us a bit. TC, I'll just call it TC. Carried us into one unknown, and now we know it. It's late, right? And I don't even think if I start explaining many grammar, I mean we've had a lot today, right? So what I will do is, yes, about the workspace, don't push your entire workspace. We don't do that here. You are going to, there's what's called a git ignore. Yeah, but in this case, no need for a ignore, because all you need is just this, all these folders. So initialize your gits inside this repo. Let me walk you guys through that procedure again. But I shall not write it down because we already have a class. Like there was a tax on that and that's why we had that task to start with. So we create a new repository. A new repository. Let's call it tax for submission. Tax for submission description. Okay, nothing came to my head. So git initialize but you don't have to copy everything. All we need to do is we need to initialize git in that repository, in that folder. Again, CO, this folder that has the package. I don't want the folder with build, with many things. We are not doing that. We're not doing that actually. Yeah, okay. So I will now proceed to git initialize, and then yeah, we have git. Now if I do ls-la, we have a git folder, and if I come back here, we have a git folder now. We didn't have that before. So if somehow your git folder is showing outside here, I really don't know. But for people that have used Rust, this is like probably a different way. The most common way is to initialize the git repository outside here, and then use like a git ignore to remove these three and have only this. But since we have only one package, I'm just freestyling actually, so we can have all of this showing our GitHub repository. And then you know the drill, git add. No, we can't add to git yet because we have to. Yeah, we can add git add, and then it adds everything, and we commit, first commit or whatever. It runs some lines for us. Then we have the things down there. These are all our stuff. As you can see, we have our even VS Code. We're supposed to put in the git ignore, but I'll allow it. We have simic, we have meshes, we have everything. And then git branch, the main branch which is main, and we can now add your. I mean, these are things we've done before, so I'm just going over it because it's going to be in the recording, and you can always have it. And then we git push, you track origin and main, and it reads up, it stores kind of thing. It's going to give me a warning. It's going to give me a warning because one of the files is too large, but it doesn't matter. It's just typical. So refresh and release it. Now, if you notice, this doesn't work yet. All we have is a dog and a leg. But in the case where you don't finish, you have something up there that you have actually done something with Ross. And it's I mean, I'm not saying you should turn your GitHub to a junkyard where you just store different things on it, but over time you would have a lot of like important things. And again, since it's out there on your GitHub, it's, I don't know, for me, when it's on my GitHub, it gives me the push to complete it, because my GitHub link is very easy to find, and there are people that like ask me things on my repository or fuck my repository, and like it's pretty much out there, and it's been out there just going to give you more drive to finish what you started. So I want to believe it's this laptop that is slow, not my internet. I mean, either ways is bad, but like I was very sure it was supposed to crash. Please build the complete package. Let's have the picture at the end. Let's have the picture. Okay, want me to build my own? I mean, I can do that if you're willing to stay on the call. It's just that the call now will be too long. Nope, well, I can't have call one person. I mean, you guys support that. All right. Let's go. So do I have water? I mean, I was thinking this call will end. Okay, I don't have water. Time no day. Okay, let's do like this. Okay, Saeed is saying we should not do it. Okay, let's open the poll because me, if it's to do robotics, I'm more amount to any time. So let's open a poll and let's do it this way. Should I build the whole robot? Should I build the whole? Maybe when? When should I build the whole robot? When should I build the whole robot? Today. So, I'll speak to me tomorrow.
So I don't mean to. I don't mean to link everything up, but just come build the ready files, the ready package. Let's see the end result.
I should come build the what?
I mean, just to build the ready package, the one that we already have, because we're creating our own working space, our own workspace, right? So from your own workspace, the repo that we're cloning. So can we?
So I don't rush. Go vote. I never even drop myself. Everybody votes tomorrow, but men don't tire. It's tough. But Said, okay, it was not Said. Said, you were the one. You're the one that you were voting for the challenge. The challenge never even dropped, self. The challenge never even dropped. Oh. Okay, so let me understand what you're saying, TC.
You know, after linking the arm to the body of the robot, we run it, right, to see the graphics, right? So I'm saying, let us see everything, the complete picture, right? Since you already have it, you've already done everything, you've done the linking and all that. Can we run it? Let's see the movement.
Okay, let me tell you what you're saying is a bit. Let me explain something for you.
Okay.
The only thing we've linked is the trunk, which is like the body, to one leg. That's the only thing we've done. No? You would have to link the body to 4 other legs or thighs, and then link the thigh to the main leg because there are 2 components. Now, visualization is different from simulation, and I always made that point clear. Right now, we can see it. We can even use the slider to see what it looks like when it's moving. But if you want a situation where you play it and can see it working and something like that, that's when you now go into simulation. For that, you will now have to have like a proper controller for that because you want to like take your hands off your PC and run it. For that, not only will we need a URDF, we would need an SRDF or an SDF, and that is a bit out of the scope of today's class, right? Because if we attempt to do that now, like that's like a whole lot. I have to introduce that theory and then all of that. So, can you see it moving like a real dog now? No, you can't. Can you see it assembled as a real dog? You probably would have, but the votes are against you at this point in time. So it's most likely going to be tomorrow. But before tomorrow, even if all you did was to copy, even if it was step 1 or step 2, you copied the files, you cloned the repo, you copied the files into the new file. Even if that's all you did, push it first. Because I want to see, like, I want to be able to track those progress. Like, we have to actually track those progress. As for this assignment, only 41 people actually engaged it. But now, if you see something, when I wake up, I usually like as part of my notifications, I check my GitHub. I know that's a very, very nerdish thing to say, but yeah, like GitHub is like a social media. It's like your Instagram for code. So things you've worked on before, people you've collaborated with, you might get reviews. I requested for review. I requested for change on people's repo for like 3 weeks now, and there is no response to it. And I know why. Probably because you've probably not even gone to your notifications. On your GitHub, your notification is like up here. So you get to see what's going on. You get to see, oh, someone actually did like a state change. Someone made some changes. I can see who made those changes. Okay, yeah. This is, she made a comment. So the same way, if I should what do you call it? If I should make a change on your, say for example, now I make a change on another pull request, you are going to get a notification on that side. And this is my guy. I haven't still managed this. Okay, so always check your notification and try and see if you can make changes, because some people's work has not been merged. Some people's work has not been merged, like blocked from being merged, and I requested for change. You missed a step in the task, ask for clarity, fix things up. So that's what I'm trying to say. So yeah, that's it. I would send the, do I need to send the tax? I can just upload the tax. Okay, this is what I'll do. I will, because if once I leave here, I don't know what I'm going to do. Okay, I'll copy this. I will go to the repository. Where's my repository? Da 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 da. Johnny, you can call from the okay, so let me call this tax 4 guide, and let me paste this here, and I would rename this to a readme.md, so it's like pops up big, and then I would come into this readme and I will say the tax, and underneath read tax guide here, and I'll make this bold because it should be bold. Make this bold, and I will. What's the syntax for links? What's the syntax for links? I think it is. Is this should be yeah, it is. And then what would I do? I will reference it. Hold on. I would reference it from tax 4 guide /readme.md. Give yourself /readme.md. So I will make changes. I'll make changes to the repository. Make this bigger, make this bigger, make this bigger. Git status, just to be sure I didn't change anything much. It's just the readme and the tax guide. So git add, git commit, Bonus knowledge, you can actually, all your git add, git commit, you can actually put it in one script and just run it, or you have VS Code for that. So how many times do you git add and git commit? Added readme. Okay, then it's push track origin main, and it pushes, and so this is what you do. You come to the repo. As how somebody has already forked the repo. Na TC. I saw na TC. TC has already forked the repo. Oh, go. Okay, so as usual, start the repo. Now this is why I might say start the repo. We're like 60 something on the group, I'll be 70 something, and we are going to be more next time. And then if the repo is starred, you can simply come here and you can just come to your stars. Like it saves everybody the stress. Group link, repo link, repo this, repo that. Once you get the repo, I've seen someone that had the repo but lost the repo, and I know you can't put the repo in your head clearly. But I might even, I mean, just to make things organized, so we're not looking for repository link every time. So yeah, let me drop the repo link. So you come to the repository and you can see here. If you read everything here, good for you, no wahala. But this is to make your life easier. So you click on it, and this is what we worked on. That anywhere you do reach, upload something. Let me head over to get the link. Lines on the space of time calling on you, Mamila. Then the next thing is I would send a picture that has the everybody should fill the link first, so that I will send the picture once. Let me send the link again. Please do not. I'll just do that over class. Okay, so there is no mountain too great. Yeah, that's what I'm saying. Side say must get internship. Now even the CC, I just the talk for AFS. Okay, someone said made mistake. Please build. Okay, I've answered that. Time no day again. Okay, Side can watch the recording. This TC, small thing go turn militant too. Wetin they do? Wetin you do a flu man? If you want to do for robot arm, Side one get internship. The funny thing is, you are not even doing it for a robot arm. We're not doing it for robots. I mean, you are doing the taxes for the robot arm, but yeah. Okay, so I believe we have learned something today. I believe we've also gotten confused today. In either case, a win is a win. So what's going to happen is you probably watch the recording, then you start to do something. Just for reference, I really appreciate the fact that people actually watch the recording. Like I don't know. I mean, everybody is different, but I can hardly finish a recording. Right? So I'm just doing this. I'm just saying this to like give kudos to you guys that there was someone that like watched the recording. It was then we're doing installation. you watch the recording and actually took time to get the commands from the recording, not from the chat. So it's either, I mean, even if you say he was screenshotting it and sending it to ChatGPT to give me this as a text, it's still effort. That's a lot of effort. So it makes things easy. And I mean, kudos to people that actually take time to study these recordings. It's something that I can't even do, right? So yeah, you got what's OCR again now? Blood. I can see. I confess OCR. Oh yeah. Sometimes my head is slow. Either ways, yeah, that's that about that. So we continue in the group chat. We're going to have another class tomorrow, like to follow up, because something like this, if you leave it for too long, talk. But before tomorrow, I still want to see something on your GitHub. I still want to see something on your GitHub. So, any question? No questions. All right, we'll see in the group chats. Recordings will be available shortly.